variable called value. Getting a copy of 9, this did not happen. Value becomes A. Then insert at front called get new node. And get new node said that it wanted a node type as well. And he has a reference parameter value. So instead of creating another one called value, again, same principle. This does not happen. This value belongs to this function. This value refers to this value, and this value refers to A. That's what I have. So visually, this is what we're working with. And notice what happens. He calls operator new, right? What does operator new do? New says, what do you want me to build for you? And you said, I want you to build me a list node object. So what's the first thing that new does? New calculates. You don't have to worry. You don't have to worry. You just tell him what you want to build. New calculates how many bytes a list node takes up in memory. Let's just say randomly. Let's just say it takes up 20 bytes. Okay? He goes into the heap. Remember, new works with the heap exclusively. So now new goes into the heap and he checks the heap. Do I have one chunk of 20 bytes? And he finds it. That's the first step. He finds it. The second step, he actually has to build the list node at that location. So he's going to call the list nodes constructor. And remember, the list nodes constructor wants a value. Let me just show you again what the list nodes constructor looks like in case you forgot. This is the list nodes constructor. The list nodes constructor wants something of type int. He's going to initialize the data part. This is what a list node looks like, right? A list node has a data and a next. So the constructor says, give me an int. So we're going to pass in 9. So the data will become 9 and his next will become 0. All right? So that's what's going to happen there. Okay. And so this is what just happened. Get new node. This calls the constructor for this guy. So right now, this is exactly what you can imagine. He just built a list node object, For the data part, he put in 9. For the next PTR, he put in 0. Now, everything you built has an address. So let's pretend his address is 500. New will now return. What does new actually return? Does he return this object?
No, just the address.
The address. So he returns 500. So this 500 gets returned. Returned where? Where does this 500 get sent back to who?
The pointer.
No, but be more specific. Like, who called this function? Who called this function? Where were you? Where were you when this function got called?
Insert at front.
Insert at front. So this 500 will be sent back to function insert at front. So let's go back to insert at front. And here it is, right back at this point, right? So now 500. So pretend that this sent back 500. And who's on the receiving end to get that 500? New PTR. So if you want to visualize it, this is what I want you to visualize. A new node was built. It contains 9, null, 500. Who knows where this guy is? New PTR. So up to line 66, I want you to really understand, up to line 66, this is what it looks like. You still have your list. This is your list object. This is the newly created list node. Can you say that this guy is a part of this list at this point?
No.
No. All you did was you build a list node. Nobody gives a damn. You just built a list node. I need to somehow get this list node to become a part of this list. So now, you just have to use logic, right? If this is the only node, right? He would be the first guy, and he would also be the
last
guy. So visually, I know that these two would be pointing here. But let's see how the code works. The code, first thing it checks to see is if is empty. Let me just show you what the code for is empty looks like. Before I show you the code for is empty, how would you be able to tell me if a list is empty? Like looking at this, let me just show you. This is your list, right? This is your list object. How would you be able to tell if this list is empty? What does it mean? Okay, let me rephrase that. What does it mean to say that a list is empty?
If first PTR and last PTR is null.
Okay, well, that's true. That is correct. 100% that's correct. But what does that mean? Give me another simple way. What does it mean for a list to be empty?
There are no node objects.
There are no node objects. This guy has no list node objects. So I'll just show you the code for is empty. You see how simple is empty is. Where is it? Is empty. Is empty. Look at it. One line. One line. He just returns if first PTR is equal to null. If this is null, obviously your list is empty, correct? So in my case, right, in this current example, is this true or false? Does this return true or false?
True.
True. True. Is first PTR null right now? Yes, it's null. Yes, it's null. So this returns true. So since it returns true, what do? We say last, whatever address new PTR has, I want you to have it. He says, okay, what is new PTR? It's 500, so you get 500. This is what this looks like. And then first says, whatever last has, I want to store that. Oh, so then this becomes, but this is what it looks like. This else doesn't run. And now what's going to happen? You leave this function, insert the front. So value is gone. All right. New PTR is destroyed because new PTR was only created inside of this function. And this is what your diagram looks like right now. You have a list with a single list node object. Do you follow what just happened?
Yes, sir.
Let's add another one. So now I come here and I tell the same list object, right? The same list object. I say, hey, I want you to add another, right? B. And remember, B was, I think B was 5, right? Same thing is going to happen. So this is B. So this is, let me just try here. This is B. Contains 5, right? The first thing that happens, we pass B to this function. What does this function do? He creates a parameter called value. Value does not get a copy of B, he becomes B. So I'm going to put value right next to B just to show you. Then this guy, insert the front calls, get new node. And if you recall, get new node said, give me an int. So I give him value, right? So then inside of value from get new node, value from insert the front. Then what does get new node do? I'm not going to show you again, but he's going to build us. What does he do? He builds us one of these. He builds us a list node. What's going to be the data part of this list node he just built?
5.
5. And his next is null. Let's give this guy the address 700, right? Let's just make it simple. Now, when list node is done, he's going to return 700. All right. And 700 will be sent. And who's going to be created? New PTR. So currently, this is what it looks like. New PTR stores 700. So up to this point, this is what I have. This guy is a list node, but he's not part of my list. So the first thing I do, I check. I say, hey, list, are you empty? Is this going to return true or false?
False.
False. Because remember, is empty checks to see first PTR is null. First PTR is not null. First PTR is 500. He stores the address of this node. So since this is false, I come to the else. Now, this is the important part. Remember, this function says, where's this pointer head? Where is it? Okay. This function, right, says I will insert a node at the front of the list. So you need to imagine that when this is done, this guy should be at the front, this guy should be number 2. Does that make sense? So how do I make this guy the first guy and this guy the second guy? Right now, first is pointing to him. How
Wait,
do I
sir,
do that without losing this guy? Well,
sir,
it's
so
If you pointer,
so int A will become the second one in the list.
yes, he will become the second one because this function says every time I add a new one, that new one will be the first guy. Every time I add a new guy, that will
Okay.
be the new first guy. So since this is the current new guy that I just built, he needs to come here. So my question is, how do I attach this guy to this list without breaking anything, but also making sure that he's at the first position?
let the pointer
Well, what would happen if I just wrote this? What would happen if I wrote this? I said, oh, okay. Oh, God. I have to reprogram this stupid button, man. Oh, my God. Is there a bug? Can I go back? Control Z? No. Okay. Okay. I have to reprogram those stupid buttons to stop being clear. Hold on. So this is what I have so far. I have LI. I have 500. 500. And then I have 9. Okay. This is what I have so far, right? I just built this dude. He contains 5. His address was, and who knows where he is? New PTR. I need to get this guy to come here. Now, what if I wrote this? I wrote first PTR is assigned to new PTR. What if I wrote that? What that would say is, stop pointing here and point to whatever new is pointing to. And that looks good. That looks good, right? Because he is now pointing to the first guy. This is the new first guy. And then I would say new PTR, point to who? That's the problem. How do I get this guy to attach to this guy? You might say, oh, that's easy. Just write new PTR is assigned to last PTR. But this is a problem. You can't do this. You can't say new PTRs. Sorry, this should not be that. This should be new PTRs next PTR.
Sir,
Is assigned last PTR. Why is this not a good choice? Because if you had more than one node, right? Let's pretend this list already had 5 nodes. List last would be pointing to the last guy, right? What would happen to other previous 3 nodes? That bond would be broken. Understand? I can't just say, first, point to this new guy, because if there are a bunch of nodes here, all of those would be lost. All of those would be lost. So this cannot be the first step. This can't be the first step. The first step would have to be tell this guy's next to point to whatever first is pointing to. Does that make sense?
Because first hold the first node.
So instead, hold on.
So you
So
put the
instead, I have to do
new PTR, that next PTR equals the first PTR.
Are you serious? PowerPoint is not responding?
typical with Microsoft.
Yeah, sir. If you had a map, that wouldn't happen, sir.
Oh, really?
Yeah.
And I'm a Senator's board.
That's a point. I think because of the tops,
I think Gilbert is a Apple fanboy. What do you guys think?
Much more is from
Silent
me,
are
though.
also fanboys and girls. We know who you are. We know who you are. Don't worry. It's okay. It's okay. It's okay.
Steve dropped that too.
So now, what do I have right now?
Sir, you had tried that all over, sir. Whoa.
I have alive, first, last, 500, 500. Okay. This is 9. He's at 500. No, right? I just built this guy. He contains 5. His address is 700. And new PTR knows where he is. So what do I do? So I follow this line, right? It says new PTR is next. So new PTR is next. This is new guy, right? His next should get whatever is inside of first PTR. So what's inside of first PTR? 500. So I'm going to make this 500. So that means this is what it looks like. And then it says first PTR, you stop pointing here. Point to this guy. So who knows where this guy is? New PTR knows where this guy is. So now this becomes 700. So now this points here. All right? And that's no longer the case. Then this guy gets destroyed. That's what it looks like. Does that make sense?
Makes sense, sir.
So now this is the first guy, and this is the second guy. Let's add another one. We had C, right? I think C was 21. I don't know. So the same step's going to happen, right? So this is C, contains 21. We pass C to insert at front. Value gets created. So value refers to C. Then we call function get new node. We pass in value. So there's another value added on to this list here, there. Then get new node builds one of these things, right? So get new node builds us another list node, puts in 21 for the data and null for this. And then let's say this guy's address is 509, right? Let's say his address is 509. Then he returns 509 and new PTR stores 509. This is what it looks like right now. And we just follow the rule. Is the list empty? False. It's not empty. So what do? We tell this guy, the guy who just got built, we're going to say your next should store what? What should his next store?
The address found in first pointer.
Whatever first PTR is storing, he says, I'm storing 700. So he says, all right, you store 700 as well. So what does it look like? It looks like this. But if I leave it like that, right? If I didn't have the second line here, if I left it like that, first still thinks that this guy is the current first. So the next step would be, I need to say, first, you should store whatever is inside of new PTR. So that's 509. So then it should become 509. So he will stop pointing here. So this should now be 509. So now look at my list. Starts here, goes here, and goes there. Does this make sense to you guys?
Yes.
And I can just keep on going and going and going. Any questions about this?
All right, so the process is like the same thing as the second one.
What do you mean?
I guess when it comes to like adding the nodes to the first at the front.
I don't understand what you mean by this. This function just adds nodes to the front. Every time adds nodes to the front. Every time I call this function, he builds a node, adds it to the front, adds it to the front. Every time a new guy will be added to the front.
All right, process is the same. Nothing changed.
It's the same principle, yeah.
So for like insert at the back, that is same concept.
Same concept. So now I'm not going to. Hold on. Let me do how do I do a screenshot of this?
One off a point today. Next one, then last week I
So
a point
let's-
today.
Sir, so the data portion for the first LI becomes 509?
The what? The data portion for what?
Yeah, for
Yes.
the first one, that becomes 509.
The data portion of this guy?
Of the first one.
This is the first one.
No, he mean like
One of the
List?
the list thing.
Oh, list,
Left and
yeah, because
last.
remember,
Yeah.
the list keeps track of two things. Who's the first guy in my list? Who's the last guy in my list?
Okay.
So that's why he stores 509, because this guy's address is 509. All right.
Oh, okay.
He doesn't care about the middle guys, because once I know who the first guy is, I can get to the second. Once I know who the second is, I can get to the third. All right, and so forth. So that's what I have so far. Does that make sense?
Yeah.
Yeah,
So now,
makes sense, sir.
what if we want to do insert that back? So I don't want you to look at the code. So right now, this is what we have. So far we have 509, 500. It looks like this, right? Uh, 700. What was it? 5. And this 700. That's what it looks like, right? This is what my diagram looks like right now. Does that make sense? So
Yeah.
now, if I said, do an insert at back, and I have this number, let's say I have D is 50, and E is 38. So let's just pretend we want to insert node with the value 50 and another one, subsequently another one with the value 38. How would you do it? Don't look at the code, just visually. I want you to visualize what this diagram would look like after I add a brand new node with a data of 50. What would it look like? Visualize it. What would it look like? What would it look like? Because this is an insert at back. If it was insert at front, you know what it would look like, what this thing would look like. But insert at back, what would it look like?
So after address 500, we'll just have another node after it.
Right. So if just visualizing this thing, right? Visualizing this thing, I would end up with and then this would be gone, right? So then this would point here, correct?
Yeah.
This would point here, no longer there. And then let's say this guy's address is 600.
Sorry, much easier the way you do it with a first pointer to the first node and a last pointer to the last node.
Right, right.
Right there with just one head pointer, and then I'm gonna have to introduce a temp variable when I try insert at the back. But since you track two with two pointer, and much easier.
Yeah, much easier
So
for you.
how do I do this now? What would be the code inside of insert at back? What's the first thing I insert at back has to do?
Function.
Allocate
Call
a
get new node, right?
Right.
So he calls get new node. That's why it's a helper function, because you see, multiple people are calling get new node. So get new node builds a new list node object for us, puts 50 in the data. Now, let's say give an address of 600. Then what's going to happen? He returns 600, and then we have new PTR, which stores the address of this guy. And because I did insert at back, I need for this guy to be attached to my list, but at the back. Now, how do I do that? Well, I need to find out who the current last guy is, correct? Who is the current last guy? Well, it's very simple for me to know who the current last guy is.
Because last
This guy always keeps track. This guy always knows who the current last guy is. He says the node whose address is 500 is the current last guy. With that information, so far you've built the node. With that information, what would be the next line of code? Tell me.
new PTR dot next PTR equals the last pointer.
You saying new PTR,
That'll be
PTR. This is what Gilbert is saying, right? Is the sign what?
The last pointer. That store the
So
the
you
address of the
you said the last pointer has 500. So this is what you just said. You said this. Zoop, that's what you just said. Is that what you wanted?
And then you need another line, which is last PTR equals to new PTR.
Wait. And then what? Say it again. And then what?
Last PTR equals to new PTR. So no, the last pointer, the actual point to
So then this will now point here. Is that what you're saying?
yeah.
Does that look right to you? So you go, this list goes here. Shoot, man.
No, sir. That no it, Chief.
This list will start. This is what Gilbert is saying. Gilbert is saying, right? Remember, he's inspired by Apple. Starts here, goes here, goes here, right? After this point, where does he go?
PTR.
Where does he go after this point? Let me clear it up so you can see. Shoot, man.
Which one is the new PTR?
Freaking hell. I hate this stupid worthless piece
Sir,
of
wait, go back though.
Anyway, so what Gilbert said was wrong. Let me just so this is the new guy. What was it? What was the value? 50. And this was address 600. What Gilbert said was, he said, this guy should point to this guy. And then this part should point here. That's what he said. So this list starts off like this. Boom, boom, boom. And it goes, what? That's what we just built. Right? That's what Gilbert's instruction did. We got here like, boom. Is this what you want? No. I need for this guy to come after this guy. All right? I need for that guy to come afterwards. How do I do that? So I need to okay, sorry. I need for what should I have? What should happen now?
You just have to assign the next pointer to the new address you just to the new node.
Right. No. So this is okay.
Because you just want to store the memory address at the new pointer and to the last.
Right. So new PTR. What do I need to do? If this is inserting at the back, whoever the current last guy is, right? Who's the current last guy? This guy, right? He's the current last guy. Question is, who knows where this guy is? Who knows where the current last guy is? Who's constantly keeping track of who the current last guy is?
Last pointer.
This dude, right? So I need to dereference. I need to tell this guy, come here and go to this part and set this guy's address to this guy's address. That's what this code does. This code says last PTR's next PTR. This is last PTR. His next PTR, right? This part basically should get what?
The memory address of new PTR. Sure, so that last
That
point.
it looks like this, right?
Sure, so
And then the last step would be what?
Two data memories though as well.
I need to now tell this guy, you will now point to whatever new is because he's the new last guy. So now this becomes, so now your list starts here, goes here, here. So if you were to add another list node at the back, if I were to add another one at the back, same process. He's going to create one of these. Let's say the value was 38. Let's say his address was 400. Then this is new PTR, right? Same principle. I'm going to what? Take the current last guy. This is the current last guy. I'm going to set his next to whatever this guy is. Who knows where the new guy is? New PTR. So I'm going to say last. Look at it here. Last PTR. Look. Last PTR is next. Last PTR is next is here. You should get this guy,
Right.
which would be 400. All right. So what that does is it means that this now points here. All right. And the last step is this is no longer the last guy. This is the last guy. So I'm going to say last. Look here. Last. You should point to whatever new is pointing to. So new is pointing to 400. So now this should become 400. So now all right. That's going to look like this. So now the list starts here, goes here, 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 here. And that's how we did insert at front and insert at back. This will end in 4 minutes. Do you want me to give you an extra like 5 or 10 minutes to show you how to remove from the front? Like explain how it works? Or you want us to end exactly when this thing ends?
Extra, sir.
Okay.
Sir,
So you
I
have to
kind
leave-
of don't
you have to
understand
leave,
the
you
little
can
arrow
leave.
symbol.
Huh?
I kind of don't understand the little arrow symbol that you find at like line 72 and 87. The little arrow symbol.
Okay. Okay. So let me try to explain that, right?
Like, does it have a function? Or what does it do?
So let's look at this. If I don't erase this, let's just do one example, right? So this is what we had. So let's say we have this, right? Let's say its value is 21, and let's say we have that. Pretend we're working with this diagram right now. Okay, so this stores 700. Let's say we have this diagram, right? And I want to insert a new node at the back. So we call get new node. Get new node builds us a node, and let's say its value is going to be 15. And let's say its address is 6,000. When new builds this object, he's going to return the address of 600, and then we have a pointer waiting called new PTR. So now new PTR stores 600. I need to get this guy attached to the back. How do I do that? Well, I need for this guy, who's currently pointing to null, to point to this guy. Who knows where this guy is? Who knows where this guy is? New PTR does. So the question is, so Azer is asking, what is that arrow? Now, the question is this, how do I get to this part? By the way, when this session ends, I'll just restart it. You can come back, right? The question is, how do I get access to this part of this node? Well, remember, who knows where this guy is? Who knows where this guy is? Who knows where this guy is? This guy does, right? Remember, this is my list object, and my list object has last PTR and first PTR. This guy knows where this guy is. So now remember, what happens when you dereference something, right? If I dereference last PTR, what happens if I just did this, right? If I just wrote dereference last PTR, what does that actually do?
Good 9.
It takes me to this node, right? But this node has how many parts?
2.
2.
Two parts.
So this by itself is not enough. This just takes you here. But how do I refer to the data, or how do I refer to the next? I would say, okay, dot, and I would say next. Now this, the references took me here, and a dot next PTR said, okay, now give me this part. But then I have to put this in parentheses because the dot has a higher precedence than this. So the arrow is the equivalent of writing this like this. The arrow is the same as this. This arrow is the same as if though you wrote the reference followed by a dot. It's just a shorter notation.
Oh,
This
okay.
means
Yes, sir.
go to that location. Once you're there,
All right, we back.
yeah. All right, so 38 people, 37. Let's just wait a little bit. I don't think you guys understand how hard it is to teach data structures online. This is a nasty class to teach in person, much less online. That's why drawing it is like a pin. You can't even imagine what happens when you start to draw trees. Ooh. All right, 41 people. Okay. Let me share the screen again. So Azer, do you understand what's going on? Oh, hold on.
Yeah, sir. It's just basically a shorter notation for the dot and the
The reference dot.
reference. Yeah.
Because if you dereference last PTR, that takes you here, right? Okay, so I'm there, but there are two parts. So the compiler needs to know which part are you referring to. So then I would use the dot. I would say dot, give me this part. But then you have to put this in parentheses because this dot happens before the asterisk. I needed the reference to happen first, then the dot. So I have to put this in parentheses. Instead of writing all of this,
Got it.
just do last PTR arrow next PTR. Does that make sense?
Yeah, sir.
Everybody go to this. So let me add these two people. Ivan the Great and Alessandro. All right, so we have 43 people. All right, so let me minimize this. And I'm going to open this whiteboard. I don't know how long this will take to load up because this usually, I don't know why this takes. Okay, good. Oh. Clear. All right, so let's do a diagram now. Let's build one. So I have uh, 22. Okay, so this is my list object. This is first. This is last. I'm just going to draw something right now, right? Let's pretend this is what we have. This is what we're working with. 10.
Frig, I'm hungry.
Me too. Pretend we have this list. Now, what if I said I want to remove from front? All right, how would you remove from front? Before you even talk to me about code or logic, right? I want you to visualize. This is what we have right now. If I told you remove from front, what do you visualize will be the result after that operation is completed?
Address of 500 will be removed.
What's that?
Address of 500 will be removed, and 21 and 70 will be as.
So this will no longer be 500. This would be what?
7.
70. And then so this would be pointing here, correct?
Yeah.
So your list will start here. It'll be here, here, here.
Yeah.
Perfect. How would you do that? How would you guys do that? You already know the logic. If I remove the first guy, then this will be new first guy. I need to get rid of this dude. How do I get rid of this guy? Without creating a memory leak. How do I do that? What's the first check you need to do?
If null,
If what?
if it's null,
If null. I need to check if what? If
this is empty.
sorry, you're right. So if is empty. So if the list is empty, then what would happen? If you called remove from front and list was empty, what would you do?
You can't delete anything to the list.
You just return, right? There's nothing for you to do. Now, if it's not empty, what are you going to do? Since it's not empty. In our case, it's not empty. What are you going to do? I got to get rid of this dude. I need to make this guy the new first guy. Give me the logic. What would you do? Let me check the chat because I see people publishing books right now. I don't know. Look nice. Man's hungry, yes. All right. I don't know what the hell. You guys are not answering my questions. So, how do I get rid of this guy? You guys realize that you can eat, nobody cares, this is not like the lab. You can eat and listen. How do I get rid of this guy? Nobody knows.
Sir, not deleted.
Huh?
Yeah, deleted.
How though?
Using delete.
Using delete?
I think you'll need a loop to go through the each nodes.
Why would you want to go through all the nodes? I just need to remove this guy. This is the guy I need to remove.
Point last PTR to the second node and then delete this.
Let's do this, right? Let's write code and see if it works, right? When I'm done, what should it look like? When I'm done, first should point here, correct?
Yes.
Yes or no?
Yes.
So let's do that right now. Let's do the first thing and see if it's correct. I want first to point here. So instead of pointing to 500, I want first to store 70. How do I do that? Tell me that. That's the first thing. Don't worry if it's right or wrong. You just tell me exactly what I want. Tell me. I want
First PTR,
stop
next
storing
PTR.
500. I want this guy to store 70. How would you do that?
First PTR.
First PTR is assigned to what? How do you get this number? Who knows what this number is? Who knows what this number is?
Next.
New PTR, next PTR.
Who knows what this number is?
We
This guy,
reference the
correct?
first one.
This guy. And who knows where the first guy is?
First,
First PTR.
So then I'm going to say first PTR,
next.
this, right? What part?
Next PTR.
Okay. So this will give me 70. So this says, put the 70 where? In first PTR. So now this becomes 70. And all of a sudden now, he stops pointing there, he points there. And you go, damn, that was easy. That was easy. Who thinks this is correct?
That's wrong.
Not just wrong, but this is very, very wrong, right? What
Because you know what, just delete that, you just left it, broke it apart and left it there in the space, you know.
So you just created a memory leak. On the heap,
Exactly.
this is no longer accessible. You
Yeah,
just
they-
lost
just
all of this. Nobody knows where this guy is. Okay? Because you just said point here. Now, he doesn't know where this guy is. This guy knows where this guy is. The guy after, not the guy before. So you cannot, this can't be the first step. This can't be the first step. So my question to you now is, what should be the first step?
We must have to create. No.
What would be the first step?
Sir, I think you created
That node, sir.
variable.
Huh?
Create that like a
We have to
temporary.
create that node.
Create a temporary pointer?
Sir, no way me say. I don't know.
So how would you do that? I don't even know how to write the code for that. How would I do that? What type of pointer would this be?
No. List
Temp.
node.
Pointer.
List nodes. I have to do this. I'll say list node. Of what?
Of int node type.
Node type. Node type. I'll call this temp. PTR, right? So who do I want temp to point to?
You want them to point to the first.
To this guy, right?
Yeah.
Because this is what it looks like right now. I want temp. Let me just erase this so you can see what this looks like. So I want temp to point to this guy. So who knows where this guy is?
First PTR.
I'll say temp. Whatever first is pointing to, I want you to point to that. So this is what it looks like right now. This is temp, PTR. He contains. That's what that looks like. This, so far, this is all you've done. Okay, what's going to be the next step?
You call delete.
Call what?
Delete.
Call delete? On
Okay.
who?
Ah?
Call delete on who?
First PTR.
This is what we have right now. Remember, I want to get rid of this guy, and I want this guy to be the new first. What's going to be the next step? You create a pointer that points to this guy, so we can keep track of this dude, so we don't lose him. What will be the next step?
So you delete the first PTR now, right?
I don't know. You tell me. We'll try it. What do you say?
You call function delete and you pass the first PTR. I don't know.
So say delete. We could do delete first PTR, or we could delete temp PTR because it doesn't matter, right? But anyways, let's say delete.
Oh no, that's wrong. Never mind.
I can't do that.
What
You
would this
can't do
do?
that.
What
No,
would
you
this do?
can't do that. Never mind.
Right? Why can't I do this?
Because then you're deleting what's in temp and then you're gonna get your memory leak again.
No. Okay, this is very important. Delete does not
That's free up
remove
space.
what's inside of temp. Delete
Remove temp itself.
releases this memory, so this is no longer in the heap. Okay? Temp still points there. Now after you do a delete, this will be released, but temp still points to that place in memory, even though it's no longer part of the program. He still points there.
Huh?
So do you want to do that? Does that create a problem, or is it that's fine?
Oh no, that's fine if it does
That's
that.
fine, because delete does not delete the pointer. It just says whatever memory you're referring to, release it.
Oh.
So he will release it. Then what do I need to do next?
And now you assign what's in temp in the area, assign it to.
First bit here.
Wait.
No,
No,
there's a
you
problem, right? What is the
Yeah.
problem? Since
Will
you release this, that's why I'm trying to go with your logic. So since you release this, I need to get here, correct?
Mm-hmm.
Who knows where this guy is? First. So
Yep.
first is pointing to released memory. That means this doesn't exist anymore. So you can't come here because this has been released. So that means the delete can't happen yet. Because once you do the delete, you release this. So now he's pointing to released memory. So
You have
he
to
can't
point to
ask this
the
guy what's your
first.
next. So this can't happen yet.
You
It's
do
gonna
the-
happen, but not yet. So what's gonna happen now?
The first bit here is
First, we're starting for point to the next one.
So then
First PTR is assigned to
first bit here next.
first
Next.
PTR,
Yep.
First PTR.
yeah. PTR next.
Yep.
okay, and then what that's gonna do is
Point to 21. Point to
that's
70.
going to stop pointing here, and then it's going to
70.
point here. And then the last step would be
Now you delete.
delete. And now this will be released. And now your list has been maintained. Does that make sense?
Yes, sir. There we go.
All right. Any questions about this?
What happens to your temp after that?
Oh, well, remember, temp was created within the remove from front function, so it's local.
Yeah.
So he's going to be destroyed as soon as you leave the function.
Mm-hmm.
Any questions about this?
Nope.
Now, the nastiest operation is deleting this guy. You're probably wondering, why is deleting this guy a nasty operation? Just before we end up, just for a second, I want you to imagine what you have to do to delete the last guy. Just look at it right now. Tell me what you think you have to do to delete that last guy.
You must have to go node by node by node from the beginning and then try to get to the last one.
Why? Why do I have to go through all that work?
Because you can't reverse.
Because, okay, so what you always have to do is, right, visualize what it should look like, right? If I said, delete the last guy. Okay, if I delete the last guy, who should become the new last guy?
The one before
Node
it.
containing 5, correct?
Yeah.
Last should point to him. Sounds good. All right, I just need to say delete this guy, and then last should point here. Okay.
Create like a
So how do you get the address of how do you get the 800? How do you get this guy's address? Who knows where this guy is?
to go from
The node before him knows where he
Node
is.
before him. And you might probably say, oh, it's first, but you can't say first because what if I had a situation like this?
long.
All right. And I said, get rid of this guy. Then new last should point here, correct?
Yeah.
So how do you know where this guy's address is? Well, you got to ask this guy. Well, where the hell is this guy? Oh, well, I need to ask this guy. Where the
Oh,
hell is
shit.
this
Okay,
guy?
now I see
I
the
gotta ask this
problem.
guy. So that means for you to delete this guy, that's why this is a tricky operation. How would you get rid of this guy? You need to get this guy's address. But for you to get this guy's address, you need to get the guy before him. But for you to get his one, you have to get... So that means you have to do what? I need some type of what? I need some type of loop that will start from here. And the question is, how do I move next, and know that I should stop here, not here. You don't want to stop here because if you stop here, you're just like last. You need to stop at the guy in front. How do I create a loop that stops here?
You will have to check if that nodes.
While, right? Let's create a temp. Let's just create a temp pointer, right? I'll say while temp pointer. What?
Oh, is that 0?
Then what am I going to do? So let's say this is temp pointer, right? He starts off here, and I'm going to ask him, while you're next, what is his next right now? Is his next different from null? Don't worry about what it is. Is his next different from null? Yes. This says while you're different from null, it is different from null. How do I move here? How do I get temp to move here?
You do temp PTR is a sign.
Temp PTR is a sign.
Next PTR.
But then he comes here. Is your next different from null? Yes. Then he comes here. Is your next different from null? Yes, he comes here. Is your next different from null? Yes, he comes here. Is your next different from null? Yes, he comes here. Is your next different from null? So was that a good choice?
No.
Because then again, what does that do?
You're gonna still end up there.
So what should I do here instead of saying, is it different from null? The good thing is we were moving, right? It's going so good. But we still ended up right at the last guy. How do I move him but stop him right before? What's another thing I can ask instead of, is your next different from null? Is your next what?
Last pointer, sir.
Is your next equal to?
Last pointer.
Because last points here and next points here. So let's say this guy's address is 500, right? 5,000. If this guy's address is 5,000, that means he stores 5,000. And then this part stores
5,000.
5,000. So basically all you're going to say is your next different from last? Yeah, it keeps on going. And he comes here and says, is your next different from last? No, he stops. And once he stops, the easy work, it's easy after that, right? I'll just say what? Last PTR
is a sign. Temp PTR.
Okay, is assigned to
Temp PTR.
temp. And then
you delete.
Then
Now you can.
Then last, which is now pointing to temp. Last, next. Sorry, then delete. Last, next. All right, it's going to release this. I mean, there's another, you could write it in a different way, but that's the general idea. So that's how you do remove from back. And the code is right in the slides. Again, you can always refer to it. Let me just show you. And we can read it.
And sir,
yes.
Will it be the same process as removing from front?
What is the same process as removing from front?
Will I give you the same logic?
No, remove from front is easy. We just did remove from front, right? Remove from front was just a couple lines. It's simple. But the remove from back, that's the tricky one. Because remove from back, right? We create a temporary pointer. And then we have to use a loop. And we keep on checking. When you get to the one right before, then we do this. And that's it. That's it. So now we've finished the code for the linked list. I will send you later on today 2 functions that I want you to write for me. So that's why you need to make sure this code compiles. So when I give you those functions, you can test to see if they actually work. All right? So do you have any questions before we end?
No, sir.
All right. So review this. We've now officially covered everything having to do with the list. I'll tell you 2 functions I want you to write. Before you submit those functions, please have this code working so you can plug it in and you can see if the results are exactly as you're hoping for. All right? Then you can give me those. You can work in groups of 3. This will be due on Tuesday. I will email you what the 2 functions are that you have to build.
Sir, is it due Tuesday before class?
Yeah, before class.
Okay.
Sir, I think 2 groups, 4.
That's fine. That's fine. Why will 2 groups have 4? Any questions? All right, guys. So that's it. Please review the stuff. And I'll look out for my email and then you can work on that. All right?
Alrighty, sir.
All righty. Take care. Enjoy your weekend. Adios.
Adios.
Later.
Okay, ma.